Okay, if you're a QSI student, this is the last essential unit in Algebra 1. It is chapter 10.1, and we have several units, chapters to go in here. I think it's 8, as a matter of fact. And this is actually starting the most challenging unit, I believe. But let's get to with this. 10.1 is really easy, and basically what you're doing is, in this case right here, you are actually combining all the terms in one section. So, for example, in section 1, here, let me pause this for a second. So you're combining all the numbers in this area right here with all the terms in this area right here, not just the numbers, but the terms. And one of the things you need to know is if you go to page 576, like it shows up here, you really need to learn the vocabulary, or you won't be able to be successful on this exam, because it asks questions in terms of the vocabulary. So let's go with some vocabulary really quick, in that this number here is the leading coefficient. I'm going to put L dot C so you can remember that. The constant term in this situation is the 1 constant term. And this here, the exponent, is called the degree, or the degree of degree. So if we were to look at this, we would be able to state that, and the one with the purple underlined, is that the degree for which this this polynomial is at is, this binomial is that it is a quadratic, because it is a cubic, because it has a degree, the highest one is the degree of 3. While this one here is only a degree of 2, and that is a quadratic. If it had a 4, if the highest degree that it had was 4, it would be a quadratic. So just remember those terms as we go through here. So let's challenge this problem, and it's a pretty simple problem in that what we need to do is we need to combine like terms. So the like terms in this situation, let's start with one that doesn't have a like term. This is the first one right here, and I'm just going to write this whole side with 2x cubed. I have another like term right here. I have a like term with this one and this one. That's a negative 6x squared plus a negative 4x squared, which gives me a negative 10x squared. Those are like terms. I'm going to try a different one. Now, this 5x positive and this negative 3x are combined together, which gives me, in this case, a positive 5, and a negative 3 gives me a positive 2x. And finally, the last like terms are the constants in this case, which is a negative 3 and a positive 1, which gives me a negative 2. And this is my answer. This is how we added these two polynomials. Here we are. That's my answer. So remember, I did the circles in different colors so that you can see or visualize that I combined like terms in these polynomials. This second one is a little bit different. It's a little interesting because I'm subtracting 12 from this polynomial, this equation here on the side. And how do I do that? I guess the first part is you have to remember, and a little secret I tell my students is that there is a little imaginary 1 in front of here. So this really, if you want to look at it interesting or in a different way, it's 12 minus 1 times y cubed plus 4. This helps me remember that if I have a negative 1 here, I'm going to have to use my distributive property to everything inside. And now I get to go 12 minus y to the third minus 4. And now I could do is I could combine my like terms, which in this case are the 12 and the minus 4. And that should give me negative y cubed, and 12 minus 4 is 8. Positive 8. And that's my answer. Don't forget that little negative from there. You make everything inside the parentheses negative. And that's where students make the mistake very, very, very often. This third example is a little bit more complicated. It has addition, some subtraction. I'm going to give you a second to try to do that. So why don't you pause the tape right now and try to work it out on the paper and see if you get the same results that I did. So now that you've tried it, how do we combine this binomial, which is 2 terms in it, with this trinomial right here, which is 3 terms? So let's combine our the ones with the similar like terms. In this case, the leading coefficient is 2, and it's -3, and the degree is 2 and 2. The two powers that are the same are this one. Let's combine those two because we're adding, we don't change anything. So it becomes a -4a squared. We're adding, not multiplying, and that's why we do nothing with the exponent. Do we have anything that can combine with this 4a? No, so we just bring it down, plus 4a. And now I have this number here and this number here. And 5 combined with a -6 gives me a -1. So my answer to this is -4a squared plus 4a minus 1. And if you got the same answer, you're doing great, and you're ready to challenge the work in the textbook.